Hello my dear students, we'll start explaining to you how to write the diagram of the galvanic cell. How to write the diagram of the galvanic cell. Galvanic cell is the cell that produces electric energy by the chemical energy which is stored inside it. So how can we write the diagram which represent what happened inside this cell? The diagram starts from the left side. This left side represents the anode half cell. So we have to write the oxidation reaction written of two oxidation states, the elemental form and what happens to this elemental form. It is oxidized. And on the other hand, what happened to the cathode? The cathode ion positive 2 reduced to cathode ion 0. So what is between them? It is the salt bridge. So how can we write the diagram of the galvanic cell? The anode first, then the cathode. Between them is the salt bridge. Anode and its two oxidation state, the less oxidation state and the oxidized form, and cathode. It is reduced. So the high oxidation state is written first, then the reduction process. We have to indicate the physical state. Here M0 is solid. It is from the sheet electrode, and M positive 2 dissolve in the solution. It is in the aqueous form. And between the cathode and the anode is the salt bridge. Salt bridge here is referred to as two diagonal lines, and if it is a porous septum, we can refer it by an intermittent vertical line. So we refer to the anode and its two oxidation state 0 and positive, and the cathode and its two oxidation states, which including reduction process X positive 2, which is reduced into X positive 2 into X0. So we have some examples. The galvanic cell in which these reactions take place: magnesium 0 solid oxidized, undergoes oxidation process and makes magnesium positive 2 and 2 electrons. So this is the anode. Oxidation process happen here. And the cathode, which is zinc is reduced by 2 electrons. Zinc positive 2 in the aqueous solution in the salt. Ions reduced by 2 electrons undergoes reduction process and turns into zinc 0 solid. It represented by the cell diagram. Starts from the anode, which is magnesium 0 solid oxidized into magnesium aqueous positive 2, and the salt bridge, two diagonal lines, zinc positive 2 aqueous plus zinc 0 solid, the reduced form. Another example, the galvanic cell in which these two reactions take place: 2 lithium 0 solid oxidized, undergo oxidation by losing 2 electrons and transformed into lithium aqueous plus 2 electrons. And on the other hand, on the cathode, nickel reduced by 2 electrons, nickel positive 2 aqueous reduced by 2 electrons, undergoes a reduction process and transformed into nickel 0 solid. It represented by the cell diagram. Starts from the anode, 2 lithium ions solid, 2 lithium atoms solid oxidized in the solution to 2 lithium ions aqueous. Salt bridge and the cathode starts from the oxidized form, nickel positive 2 aqueous, and it is reduced on the cathode electrode to transform into nickel 0 solid. Here in our curriculum here in Egypt, it is supposed to be in the Faculty of Science. We do not We do not study the electrochemistry by balancing their diagrams, but here in the curriculum you have to make balancing of the diagram as well as the electrolytic or the electric equation or the electrochemical equation. So in general references, chemical references, we just write the two cases of the anode and the cathode. The anode here is oxidized without any balancing, without any numbers. Okay, it is oxidized into aluminum positive 3, and chlorine 0 gas is reduced into chloride 0 ion and dissolved in the solution. So here in our curriculum we have to write the balancing of the diagram as well as the electrochemical equation. Two aluminum solid oxidized into 2 aluminum positive 3 aqueous salty bridge, and the reduction process which happens to 3 chlorine gas into 6 chloride ions aqueous. So we have to put into mind how to balance the diagram as well as the chemical equation. 2 aluminum solid plus 3 chlorine gives 2 aluminum positive 3 aqueous plus 6 chloride ions. So we have to look at some examples. Write the cell diagram of this galvanic cell which the following reaction takes place. So illustrating the anode, the question say illustrating the anode and the cathode, and the direction of flow of electric current in the outer wire. So here we see that iron here is 0 in the reactance and transformed into iron positive 2, so it is oxidized, it is anode. And here nickel positive 2, its oxidation state, and it is reduced to 0, so it is undergoes reduction process. So the iron which undergoes the oxidation process is the anode, and nickel positive 2 is the cathode half cell. So the anode is iron, and the electrode and the cathode is nickel. The direction of the flow of the electric current in this case is from the anode to the cathode. So iron 0 solid, one diagonal line transformed into iron positive 2 aqueous, and 2 diagonal lines which represent the salty bridge, and the 2 states of cathode, nickel positive 2 aqueous transformed into nickel 0 solid and deposited in the cathode electrode. Another example, here a galvanic cell is represented by the diagram 3 zinc solid oxidized into 3 zinc positive 2 aqueous salty bridge, and 2 chromium positive 3 aqueous in the solution is reduced to 2 chromium atoms. So what really happened in this cell? Which of the following about this cell is correct? Electron transfer from zinc to chromium. Zinc is oxidized, yes, look at this. Zinc here is 0 and zinc here positive 2, it is oxidized. So electron transfer from zinc, yes, to chromium, yes, it is correct. Another example, a galvanic cell represented, wait with me, a galvanic cell represented by a cell diagram. 2 aluminum 0 solid is oxidized into 2 aluminum aqueous positive 3, the salty bridge, then 3 chlorine gas is reduced into 6 chloride ions in the solution. Okay, so what is the ionic equation which represents the oxidation reduction reaction in this cell? Here, what is the ionic equation which represents the oxidation reduction reaction? So the oxidation reduction reaction, we can identify it by the diagram. This is the first, look with me. This is the first reactant and this is the second reactant. This is the first product here and this is the second product. So we can write it: 2 aluminum solid plus 3 chlorine gas gives 2 aluminum aqueous positive 2 charge, positive 3 charges, and 6 chloride ions. 2 aluminum plus 3 chlorine gas gives 2 aluminum positive 3 aqueous plus 6 chloride ions aqueous. The idea here is that the first thing in the diagram is the anode sheet, and the first thing here is the cathode. Okay, and the second one here, aluminum, is the product, the first product, and the second here is the second product. So it is easy. 2 aluminum, look here, 2 aluminum, this is 2 aluminum, 3 chlorine here, 3 chlorine gas is oxidized into here aluminum, 2 aluminum positive 3 plus 6 chloride. So if we want to write the diagram from this equation, how can we write it? 2 aluminum solid, 2 aluminum solid, one diagonal line gives 2 aluminum aqueous positive 3. Then we write the salt bridge and start with the cathode. 3 chlorine gas molecules is reduced into 6 chloride ions. So we can write from the diagram the electrochemical equation, and from the equation the diagram. From the electrochemical equation the diagram. Let's take another example. Which of the following is the cell diagram of a galvanic cell? The cell diagram starts with the element which is more active. So we have four choices: silver and copper, silver and copper, silver and copper, silver and copper. Which is more active, silver or copper? You have to know this. Silver is less active than copper, or copper is more active than silver. So the more active is the anode. So copper must be written first in the diagram of the electrochemical cell. So when we start with silver, it is wrong. Here silver, wrong. We have two choices, C and D. These two choices, the first one is copper positive 2 reduced, supposed to be an anode, so it's supposed to be oxidized, so it is wrong. This is wrong, and the correct one is D, copper oxidized into copper positive 2. This is anode and more active than silver. 2 silver ions reduced to silver atoms, solid. Here we finish this session, hoping that you understand all. Your comments, your opinions are very welcomed. Your advices will be noticed or will be observed by me. So keep with us. We'll explain, as we have said before, we explain everything, and we'll make a thorough revision, or a complete revision, an extensive revision for all the curriculum. Thank you.